Hi, I'm Katie.
Hi, I'm Beth, and today we're going to be doing a lab that investigates free fall during equal time intervals.
The equipment needed to perform this lab is 6 half-inch hex nuts,
Which we have here in this bag.
a kite string, a meter stick, and a pie pan.
For this activity, we will tie a hex nut onto the bottom of the string and 5 other 10 centimeters apart. And then we will drop the string above the pie pan and record the clangs, and hopefully they are equally spaced.
Step 1 is to cut the string and attach the hex nuts from the bottom up about 10 centimeters apart.
1, 2, 3, 4, 5, and 6. Step 2 is to turn the pie pan upside down to hear the clang better. And finally, it's time to do the experiment. Place the pie pan on the ground and hold the string just above it. Alright, there we go. So we'll hold one of these hex nuts just above the pie pan.
As the nuts fall, the speed goes up due to gravity. This is because the distance they fall increases. Earning instant, they fall faster and faster.
To compensate for this, one could space the hex nuts out further from each other towards the end. This would allow more time and create an equal clanging sound.
The total distance d an object falls in time is a half times gravity times time squared, where gravity is g and t is time.
This is a formula that will help you create equal time interval changes between clangs.
Now you know how free-falling objects work.
For this trial, we'll hold the hex nut steady over the pie pan and see if that makes a difference in the sounds. Ready? 1, 2, 3. You want to switch because I'm a little taller. Yeah. That one's better. It's another minute.
Now we are trying from a different height and a tin pan different.
Now we'll try with the regular tin pan that we had. 2, 3. Now we are dropping it from a different height, and we inverted the metal sheet that we had so that the sound will hopefully be louder. 1, 2, 3. Not really. Now we put the tin pan on top of the metal sheet to hopefully increase the sound of the clangs. One, two, three. We can put it upside down. We'll put the tin pan upside down now on top of the metal sheet. One, two, three. That was a little bit louder. Now we've taken the same length of string and we're going to tie different hex nuts in different spots on the string. The first one will start in the same place though. So now we've tied the different hex nuts on the string, and they're in different order. Their lengths between the hex nuts are quite a bit different. They're getting longer as they get further up the string, and hopefully this will help us get an even time of clangs. Now we're back standing on the ladder. We're using the inverted piece of sheet metal and the upside down pie pan, so we think that made the best sound. One, two, three. I feel like the first couple ones were a little more even. So we kind of ran out of string. As you heard from that experiment, the hex nuts that we used were quite a bit louder than the previous ones, and so was the two pieces of metal together. They were spaced a little bit more evenly, except for at the end because we started to run out of string. It's so loud. Now we can flip the. To sum up our lab, we have figured out that if we would have more height and more room to have a longer string, that we could evenly space out the hex nuts. I think it would take a couple more feet to actually get to the point where the clanging would be even. I think that would definitely help with this experiment. We just didn't have the room to do.
We definitely heard how gravity can affect falling objects.
And for this experiment, we could use different objects because gravity affects objects all the same in that way. Just like we use the different hex nuts. Just as long as each object would make a sound when it hit the floor so that you could hear it. That concludes our lab. Thank you.